Here we are loading the test and train data here, and then we are calling the linear regression on this model and fitting this with the train data and testing with the test data. And we are root mean square error we are calculating here, and we are printing the R2 score as well. I'll run this function program here. So this is the code which I've getting. This is the mean square error rate. This is, and this is the R2 score, and this is the graphs which we have got. That's it. Thank you. Hello everyone, myself Rajeshwari Chelleti, and my team members are Prakash Ravilla and Anusha Pala. This is a demo of our Lab 2 assignment. So this is the first program. We have taken the fruit data color text file. This consists of following information, that is, it consists of different fruit information, that is apple, melons, etc., along with other information about the fruit. So yeah, if you go down here, we are mapping the fruit with its name, that is like this. We are mapping it, and then we are printing the count of the fruits which are available. This is the count of the fruits, and then we are head function is we will display top 5 data from the table, and then we are calling the scatter function between width and height, and this is the matplotlib, and we are getting the plot, and then we are plotting between mass and color score, and this is the graph, and we are plotting a graph between height and width for the entire data, and this is the plot. Next we are calling the k nearest neighbor classifier, and between mass, width, height, this is the information, and we are describing it, and this is the table. We are loading the train set and test set. We are calling the train neighbors classifier and fitting it with the train information and testing it with the test information. We got this score, and then we call the name bias, and this is the score we are getting, and this is the SVM, and this is the score we are getting. From this course we can say that we can use any of these algorithms for this particular data set. Here this is the second program. In the second program, we are taking a heart.csv. This consists of information of different heart patients, their beat, the blood pressures, their age, etc. And then we are checking if the column is having any missing values, and if there are any missing values, we are searching for them. Then we are using the heat map in this function, and we are using a scalar and fitting this heart data into this scalar, and we are transforming this one, and then we are calling a k-means on this particular cluster, and we are calling the helper function to know the number of clusters, and we are printing the clusters here, the score here, and we are at the end we are generating a graph which will show the number of clusters and WCSS, and this is the this graph is having the name helper method, and I will compile this one. This is the output we are getting. These are the clusters which are generated, and at the end we are having the helper method graph. These are the scores which we got for the clusters. Next is code number 3. Here we are taking the data from a text file. Some of the data is not clear, like it is not recognizing some of the characters, so we are just replacing them with the proper sentences, and then we are calling the tokenize function to generate the tokens. These are the tokens which are generated, and then we are printing the trigrams which are present, and then here if you go, we are seeing what are the most repeated trigrams, that is extract the top 10 trigrams. These are the top 10 trigrams which are repeated, and then we have to add all the strings which are present in the most popular trigrams, and we have to append it one after the other without repetition. So this logic we have written here, and then these are the sentences which are having most number of trigrams according to the order we are printing here. The last program, sorry. This is the fourth program. Here we are in multilinear regression. We are using advertising CSV data set, and then we are removing any skewness, that is which is unwanted data. We are removing that which is like which is out of symmetry. That data we are removing, and then we are creating a graph. These are the X labels and Y label. This is the title of the graph. This is histogram distribution, and then we are working with the numeric features, and we are seeing about handling the null values here, and we are handling whatever null values we have detected. We are handling the null values here, and then we are plotting the graph. Then we are loading the test and train